bus slows down as it approaches a bus stop. It stops at the bus stop and remains at rest for a short time as passengers get on. It then accelerates away from the bus stop. The graph shows how the velocity of the bus varies. So you can see the velocity speed reducing when it stops and then it accelerates again. So assume that the bus travels in a straight line during the motion described by the graph. So part A then, it says state the length of time for which the bus is at rest. So nice and straightforward, this one, okay? I hope you can see that when it's at rest. Of course, at rest means the velocity is 0. So we can state that, okay? At rest, velocity is 0. It's got 0 speed. So in terms of the length of time, that will be for 30 seconds. So at rest for 30 seconds. Okay, so we did 70 take away 40, didn't we? Part B then, find the distance travelled by the bus in the first 40 seconds. So first 40 seconds is this distance here, yeah? Okay, remember the distance is the area under the graph with the velocity time graph. Okay, so we just need to work out the area here of A, okay? So the area of that there will be, well, it's a triangle, isn't it? So quite simply, base times height divided by 2. Okay, so we'll have, we can write that down, base times height divided by 2. So that will be 40 times the height of 20, and then divide that by 2. So that will be 400 meters. Okay. So part C then. Find the total distance travelled by the bus in the 120-second period. So the total distance. Well, we've already worked out the distance travelled there. We just need to work out this distance here, don't we? So we call that B. Here, the area under the graph is 0, isn't it? There's no area there. Of course, it hasn't travelled any distance. This is when it was stopped. Yeah. So what I'm going to do then for C is work out area B, and then I can get my total distance. So area B will be, well, again, base times height divided by 2. Okay, so the base in this case will be 50. Okay, 120 take away 70 times the height, which is 20. Divide the whole thing by 2, so that comes out to be 500 meters. So total distance travelled will be two distances before the stop and after the stop added together, so we get 900 meters. Okay. Part D then, find the average speed of the bus in the 120-second period. So to get the average speed, we go back to what we learned at GCSE about speed being distance over time. Yeah, when you learn that formula, speed is distance over time, we consider the total distance, right? Divide by the total time. Okay, so that's how you get the average, yeah? You work up the total distance, okay, shared by the total time it took, distance over time. So the total distance, what we know is 900, and the total time is 120 seconds. Okay, so if I work that out on my calculator, 900 divided by 120, that comes out to be 7.5 meters per second. Okay. Part E then, if the bus had not stopped, but had travelled at a constant 20 meters per second for the 120-second period, how much further would have it travelled? So essentially, I mean, in this case here with part E, we could even draw like our own little velocity time graph here, okay? Just to show what exactly would happen if it hadn't stopped and it went at a constant speed. I'm sure you can imagine now what it's going to look like, okay, because it's going at a constant speed of 20, okay, for the full period. So we have essentially a rectangle here, yeah, because that's a flat line there. So you're going back to the original graph here, because it hasn't stopped, it would keep going at that speed for 120 seconds, okay, you'd have that there. So what we can do then is work up the total distance here, and that, remember, is the area, okay, the area under the graph, Now, because it's a rectangle, it'll just be the length, which is 120, times then the height, which is 20. So that would be 2,400 meters. That's what it would have covered. But the question is asking is how much further would it have travelled? Well, okay, it's travelled 900 with a stop, 2,400 had it not stopped, so it would have travelled 1,500 meters further.